Welcome back, guys. This is my solar trailer. It's looking a little bit tired, but it was built about 3 years ago now. So on the top I've got a big Panasonic HIT 330 watt panel on it. Needs a bit of a clean. So this system is still working absolutely fine. I mean, it's not being used for anything really. So the solar panel is just literally just keeping the batteries topped up. We've got some lighting around the outside of this, so like kind of security lighting and stuff like that, which doesn't take a lot of power. But yeah, basically, let's go inside and have a look. So you'll have to excuse the junk in here because I'm using it for storage as well. But I've just kind of whipped one of the panels off up here so I can access the system and just give it a check up. But let's get inside and see if we can turn some heating on because it is freezing today. Right, might also need some lights in here, or just open this blind. Right, let's try and turn the lights on, the actual electric lights. It should be all plugged in. I can just reach around the back of here and I should be able to flick that switch on the back of the inverter. And have we got lights? Oh no, I think actually the lights need to be plugged in. So that, there you go. Right, that's it. Okay, so obviously it looks a bit of a mess behind here. There's normally a panel over this to cover this stuff up. It's always been a bit of a work in progress. Anyway, so I'll kind of give you a rough kind of rundown of what's actually going on here. So starting from the top, we've got solar charge controller. This one's a 7515. That's connected directly to the panels on the top. So yeah, basically this will just sit here and it will charge this battery. This is a home built battery made out of 26650 lithium ion cells. I think it's been so long since I've done this. I think it's like a 20 amp hour battery in here, 4 cell, 14.8 volts. You know, boxed in this little kind of thing with a voltage readout on the front, and then I've got like a sort of a trip switch here which allows you to, this is a DC one, not an AC one that you'd find like in your normal household switchboard type thing. So that allows you to turn this battery on and off, which I'm not going to do because it'll probably mess everything up. We've got a fuse box behind. So the idea with this system in this trailer, I've got a low voltage side for LED lighting. These lights aren't low voltage, these are actually mains ones. But basically this will run the outside lights on the trailer, anything 12 volts, USB, which I haven't actually added yet. It was going to be added later on, running off of this. And also, it powers this inverter. Now, this is a really small inverter. This is like a 500 watt inverter. So this is mainly for sort of convenience. If you've got something low power, like a laptop charger or something like that you want to use, you can just plug in. It gives you mains voltage basically, but not very much. You know, it won't give you much power. So this is all Victron stuff. We've got obviously Victron inverter, Victron solar charge controller, and we've got a Victron battery meter. So this just gives me kind of like remote features and stuff, and it allows me to track, you know, what's actually going on with this battery, because obviously this screen doesn't, you know, it doesn't feed back any information. It's just a readout, but this will actually track everything, total amp hours. That'd be quite interesting to see actually what the total amp hours we've used over a few years. But yeah, this system's been running for like 3 years or something, so it's still going strong. Doesn't seem to be any issues, but we're going to run some tests and just see what's actually happening. So over to here we've got a Victron colour control. This is a lovely bit of kit, way too overkill for this project really, but Victron sent me this ages ago, so I thought I'd use it. This is so cool because you can basically see what's going on with everything. So we've got a battery meter up here. That's the main reason actually why I've used this battery gauge, because it allows you to have a line on here with all the battery information. So you can actually go in here. See, at the moment it's saying we're 93% charged, we've got 14.8 volts, we've got 0.9 amps coming in at the moment from the solar panel. And if you go into here, so if you actually kind of scroll across here, you can actually see lots of other information here, like where are we, history. So this will actually give you like the discharges. Look, total number of cycles here, 342. Cumulative amp hour drawn 9,746. Don't know how accurate that is. The minimum voltage 6 volts. That's going to be bad, but maximum voltage 75. Might have been when I was messing around with stuff. But as you can see here, you've got so much scope here for, like, you know, basically it's a professional end system, which probably shouldn't be in this trailer, but hey ho. Next line, you've got the inverter. That shows you different things. Then the cool thing about this, because these are all connected by the VE bus, you can actually turn on or off the inverter from this panel or put it in eco mode, which is The main reason of this video, which I wanted to show you something about eco mode, which I believe should be on pretty much any inverter, and also power banks, you know, these power banks you're seeing around, it would be so cool to have this feature. This is the Vigapool power bank down here, which I'm not using in this trailer, but I'm thinking of integrating this into the system. Now, these don't generally have an eco mode, but more about that in a minute. So the next line down, we've actually got the solar charge controller, 7515, and we can see what state the solar charge controller's in. It's so clever. Basically, all the information is coming in directly. See that cable there on the left, that one there? This is called like a VE bus. So basically, it's like a serial connection into this colour control. Now, the solar charge controller's got one of those, the inverter's got one of those, and also this battery meter has got one of those as well. So it allows you to obviously show all the information from all the different parts of the system. So very clever. So you can see here, we've got PV voltage coming in from the roof, 60 volts, 0.4 amps is getting converted, so we're getting, you know, half an amp roughly coming into our battery at the moment. Battery voltage is there, 15.8, and the current going into the battery. Total yield so far for this system, 343 kilowatt hours. How crazy is that? And I mean, as I say, most of this is being used for lighting and just like the odd thing like charging a e-bike or something like that. I'll use this trailer for different things, but not a huge amount of power. But yeah, so you got this, and then you've got like your notifications, which you can see there's nothing it's telling us about here. And I think if we press this one, if we press that button there, you get a cool kind of diagram of what's actually going on in the system. So you can see DC power 17 watts or 15 watts coming in, our battery's at 93%, solar's 24 watts coming in, and then I think that will be the inverter. If we turn the inverter, well, the inverter's on, but I think because it's drawing such a little amount of power, it's not actually doing anything. So let's try and draw some power, and for that we're going to use the heating system that I've installed in here. So you're probably wondering what this is. I mean, it's basically a thermostat like you'd have in your house. We've got this wired up, and it's actually just clicked in, it's just turned on. So this is connected to an infrared panel, which we've got here. You can hear the inverter start to move, and this is just tripped on. You can see that little blue light down there. And these are really effective, like 180 watts, and that will make it nice and toasty in here pretty quickly. It heats you up rather than the actual space, so that's how it works. And then you can see here 161 watts, and that is basically our load at the moment. So it's not even 180, it's somewhere around 160 for that panel. And then we've got DC power going out, and we've got like 15 watts coming in, which isn't going to, you know, touch the sides of what's going out, but it's something. Now, if we go back to our other screen, you can see here, to do that, we're pulling out 11.2 amps there out of the battery. That's showing similar amps going out on there as well. The voltage has dropped to 13.8. So let's just turn this off and just see what actually happens. See, 13.8 to 14.5, and that's risen up. Let's turn back on again. So it doesn't look like the battery's sagging too much, even under that kind of low load. It's not sagging too much. Capacity is another thing. I'll have to kind of see how long this actually lasts for. It's supposed to be a 20 amp hour battery, so in theory that's going to last like 2 hours or so with this thing running. So the temperature outside is 9 degrees at the moment. I think, what we got it set to, 23.5. I mean, I don't think we're ever going to reach that in here, but you know, we'll see how it goes. But it's lovely and toasty to the touch. I can feel myself warming up. I mean, I'm not cold anymore, and temperature's going up as well, 9.5 now, so it is rising slowly. So yeah, the purpose of this trailer was always meant to be like a camping trailer, so you could kind of, you know, go out on excursions, do different things, and I can fit in here diagonally. You know, I didn't buy this trailer purposely to do this. It was the trailer that I had, and I kind of thought I'm just going to convert it for fun, and you know, use some of my kind of solar experience to mess around with. But yeah, I need to get out and use this really, because it is actually pretty cool. It's got a proper window in it, and I think it'd be quite toasty wherever you were kind of using it. It would actually work pretty well. So what I wanted to talk about was the eco kind of mode on the inverter. So basically, when you turn an inverter on and it's running off of a power supply, or like a battery, effectively, there's usually a current draw, even when you haven't got anything plugged into the inverter. So you've just got the inverter connected to the battery, and it will be pulling some current. And it can be as much as like 0.5 amp. So if you've got an inverter and you leave it plugged into a battery and you leave it on, it's going to flatten that battery pretty quickly. You know, even if you've got a big battery, it could take a day, but it might actually just flatten it completely. So this might not be a problem if you're just turning on the inverter to use the thing you want to use and then turning it off again at the end. That's actually the best way to use it. But what if you've got kind of like an inverter set up and you want to run some lights off of it, and you want to have a proper light switch, so you want to use a proper light switch like we've got over here, you know, to turn on the lights out. Those are for the lights outside, but you get the idea. So what if you want to do that and you want your inverter to be somewhere else on all the time, and you want it to be ready so that when you turn your lights on, it always fires up? And if you've got a solar system topping that battery up, you might not always get enough power, you know, in from the solar panels to keep that battery topped up. So it's inevitable that battery's just going to go flat because the inverter's on. It's got like a, you know, a parasitic draw. It's more than a parasitic draw. It's a significant current draw going out, even though there's no load. So what the eco mode does, and this isn't present on a lot of kind of budget inverters, but on the Victron stuff, they have a mode called eco. And what this does is it checks the load periodically. So it will literally go, right, is there a load? No. I'll stay into sleep. And there's kind of a predetermined interval. I mean, you might actually be able to change that interval, I don't know. But it will literally just kind of pulse on, pulse off. Now that saves a huge amount of power, and it will probably be enough to, you know, keep an inverter running on minimal sort of solar during a winter period, you know, in somewhere like the UK. Well, I'm actually getting pretty warm now. Look at that, we're up to 10.5 degrees now. Right, so let's put the inverter into eco mode. I'll do it on this screen. You can actually just do it by clicking a switch on the back of the inverter, which is a lot easier, but I'm just going to do it this way because I just like the long way around. I like the gadgety way of doing it. So you can just go in here, you can hit eco. So that is now in eco mode. Now, obviously, because there's a load, I think it's just going to carry on going. But if we turn that off, it might be enough to make it kind of turn off. Are we kind of it's gonna happen? Right, the light's on enough to trigger the eco mode. So what's happening now is it's checking. So it's going, there you go, one. I mean, it's probably what, like 5 seconds or something. Now, why is it flashing? Well, because there isn't enough load. This thing doesn't have enough time to kick in and click its relay and turn on. So we haven't got a lot of load on the system. Now, if you were to use lighting, say like maybe like 100 watts of LED strips or something like that, it would work. It would just stay on absolutely fine. If I had something around here that I could get 100 watts out of, I could probably show you, but you get the gist. So it's clicking on and off like at that interval, you know, and it's basically sensing if there's any kind of load there. Now we can actually go back in and we can just flick it back to the on state, and then it just comes right on, which is so cool. So there you go, guys. That is kind of what I'm talking about. That's flicked back on because it obviously has got enough time to trigger now. We're up to 12 degrees, fantastic. So now, because I obviously get quite a few things sent to me for the channel to review, like power banks, these big sort of inverter things with the batteries built in, you know, like the Vigapul thing that I've done the review on, 1000 watt, 500 watt, Jackery have sent me stuff. All of those, I will say to them, can you put in some sort of eco mode so we can actually have, you know, we're not talking about like shutting off the power if it's not being used. We're talking about checking periodically. So you can actually have a situation where you can leave the inverter on, ready to go, and you don't have to worry about, you know, it flattening the battery. I think the Vigapul one and the Jackery one, I think they do turn off completely, like the inverter turns off after a while to save the battery from flattening completely if there's no load, but it won't kind of spring back into life once it's turned off, if you see what I mean. So food for thought, be good if the manufacturers could start implementing this. It's been a little while since I've looked at this stuff, so there's probably other manufacturers doing this on inverters, but I know that Victron do it. They've been doing it since the beginning. So Victron, although expensive, would be a good option for this. Anyway guys, hope you've enjoyed this one. I'll catch you next time.